All right, welcome folks. Give a couple more minutes here while folks enter the meeting. If you're having any issues with sound or video, let us know. I think is the chat function.
Enter questions via Q&A, please.
That's it. Yeah. So there's a Q&A button. So if you're having issues with sound or video, let us know. All right, we'll give everyone another minute or so. All right, well, we do want to be respectful of folks' time. So thanks everyone who's attending the third session of Asphalt Institute's Odor Management Tool training sessions. As earlier mentioned, if you have questions, the Q&A function is working, so feel free to submit questions through there. We'll either answer those at the end, or if we don't have time to get to them, we'll follow up with you at the end of this call or training. Also, if you were unable to attend the first two sessions or wanted to share within your organization, those two sessions are available on Asphalt Institute's YouTube channel. So also there's a QR code here if you actually want to access the document itself. So feel free to click the QR code on your screen and you can get access to the document itself. So just a little reminder, this tool was born out of a recognition that odor issues are becoming increasingly important to member companies, and that odor as an issue is just very challenging and complex to understand. Consequently, the Institute engaged SCS Engineers to help member companies and members of the industry at large better understand the issues and provide insights how to manage those issues. For the training today, we've got two folks from SCS. First one is Mr. Paul Schaefer. He is the Vice President and Project Director at SCS Engineers, and he's also recognized as a national expert for conducting odor assessments and ambient air monitoring programs. He's considered an expert in air quality assessment specific for air toxics and criteria pollutants, as well as other odoriferous compounds. Paul manages the laboratory quality olfactometer that meets ASTM and EN methods for odor measurement, and has developed a state-of-the-art measurement technique for surrogate odor compounds specific to various sources. Paul has in-depth experience interfacing with regulatory agencies regarding the performance of monitoring systems and air sampling networks. So welcome, Paul. In addition, we have Ms. Tia Jeter with us today. She has a Bachelor of Science in Chemical Engineering from the University of Kansas and a Master's of Science in Environmental Engineering. She is a registered professional engineer and a project director with SCS Engineering. Prior to joining SCS, Tia worked for DuPont Sabine River Works in Orange, Texas, as the environmental coordinator for the ethylene manufacturing unit. Tia has over 20 years experience in environmental compliance field, focusing predominantly on air compliance for chemical industry and agriculture and solid waste facilities. So we appreciate both Tia and Paul's time today. So with that, I will turn this over to them.
All right, thank you, Shyla. So Shyla said, Paul and I are here to talk on the third webinar of the series of 3. In case you missed the first few webinars and want to go back and take a look at them, just real quick, webinar 1 of 3, we talked about what is odor. We talked about how to define odor. went a little discussion on the chemistry of asphalt odors and potential asphalt odor sources, and also asphalt odor generation and transport. Webinar 2, we covered odor monitoring options, discussed how to complete an odor assessment, and then discussed some case studies on some odor projects we've worked on. And then this third webinar, we're going to talk about odor control technologies, discuss how to complete an odor abatement plan, and then provide some insights into community outreach to assist with local odor concerns. So real quick recap on webinar 1 and 2, more so if you haven't heard some of the lingo we use, maybe it'll kind of give you a little head start on where we're at with what we previously discussed. So first, some facts about odor pollution. A large portion of the complaints issued to regulatory agencies concerning air pollution involve an odor component. And while odor is not recognized as EPA as a pollutant, it is generally regulated at the state and local level as a nuisance law. Rarely do people have direct physiological impacts from odors, but once perceived as offensive, odors can cause secondary impacts such as nausea or headaches. Perception of odors does differ by populations, and it can be difficult to quantify odor because there's no one single odor molecule. And due to that, it also makes it difficult to isolate sources of odors. As I said, it's hard to quantify odor. So what kind of science and people have come up with are characterization parameters to try to define what we mean by odor. So the first is odor concentration. And this is typically the amount of dilution required to bring an odorous air sample to a detection threshold. So it's the lowest concentration at which you would detect an odor for a certain compound. Typically, the lower the ODT, the stronger that compound is at producing a perceived odor. Intensity is a way to describe the perceived strength of an odor. There is a way to try to quantify this. It's a comparison they do with a standard, typically N-butanol and odor-free air, where you try to do a comparison. But basically, intensity will give you a qualitative scale, with 0 being not very perceptible and 6 being extremely strong on the odor strength scale. Character is looking at a description of what the odor smells like. So these are actually just adjectives of what it smells like. This could be fishy, hay, nutty, oily, sweet. There's a whole list of different descriptors you would get. If you send an odor sample off to a lab for odor panel, you would get a list of descriptors from the people doing that panel of what they smelled. And then hedonic tone is a judgment on the relative pleasantness or unpleasantness of an odor. So those are kind of the 4 parameters we look at when trying to describe odor. Some primary factors that impact odor transport, so how the odor would move from a facility off-site. There's method of release, which has to do, is this coming from a stack? Is it coming from a wall vent? The meteorological conditions at the time of the event. So is it a windy day? Is it a stable day with low wind speeds? And also the local topography and facility structures that can all impact how the odor is transported from a facility. Speaking more on the method of release, so this is specific to each source, and the first thing we look at is the odor emission rate. So this is a function of the odor concentration as well as the volumetric flow rate of the release. There's the release velocity. This will impact how far the odor can travel, as well as the potential for mixing and dilution. And the more mixing and dilution you get, the lower potential offsite odors will be. So that's we want that mixing and dilution to occur. The orientation of release speaks to, is it a vertical release coming out of a stack, or maybe it's a horizontal release coming out of a wall vent? It could just be also a pile, which is kind of emanating odors. All those things affect the release of that odor. The release height speaks to the ability of that release to mix with the ambient air. So typically, the taller, the better. The taller or the higher the release, the more time there is for mixing with the ambient air, which can reduce your offsite impacts. Temperature also plays a role in this. The higher the temperature, the higher the buoyancy, which means it'll be more likely to move up instead of horizontal or down. So higher temperature can help also increase that potential for mixing and dilution. Some of the ways we gather data and measurements, we talked about this in webinar 2. Just a kind of a little example here. We can do on-site odor measurements. This can be with field olfactometers, also commonly referred to as a nasal ranger. We can also use real-time sensors. Typically, this would be for measuring of odor surrogates. So we might be sampling for a specific sulfur compound, and real-time sensors for meteorological data. We also do sample collection. So typical methods for collecting a sample, we may send off to an odor lab or to a lab for surrogate analysis. We can use flux chambers. Direct probes are often used when you're looking at surrogate. Method 18 samplers, also called lung sampling. This is commonly used to collect odor samples. By using these lung samplers, there's no potential contamination of a pump. You go directly from the source through clean piping into your Tedlar bag. And then we can do time average sampling. With these lung samplers, you can set them up to collect a sample, like a grab sample over a one-time event, or you can set it up to do a composite over a few hours to a whole day. Laboratory analysis is used. So there are odor panels. These are actually people who go to a lab and they smell odor samples. And they tell you what that is used to determine that detection threshold, at what point they detect the sample. And they will also give you that odor character, so the description of the odors. We can also use laboratory analysis to sample for odor surrogates. This may be for different sulfur compounds. We might do some speciated VOCs to try to figure out what particular compound is causing a lot of the odor. And then there are also some analytical and empirical estimates we can use where you try to apply speciated data to some known odor detection thresholds to give you an idea or a scale of what you're looking at. And then the method of release parameters, we can use some flow measurements with sonic anemometers. We have on-site met stations for our meteorological data, and then tracers and taggants can also be used to try to assess how an odor will be transported from a facility. And then the last thing we kind of talked about on the second webinar was how to do an odor assessment. This is what we typically would do for a facility that's maybe having an odor problem, and they're trying to identify where is this coming from and how do we mitigate it. So we identify our potential sources of odors. We collect samples and measurements to define the odor concentration and the character of each source. We also take those measurements for the release parameters so we can define the flux and flow of the odor. And then we build an emissions profile for the facility. That data can be put in a dispersion model with meteorology to estimate downwind odor impacts from a facility. And then with that model, you can evaluate different scenarios. You can model what happens if I increase a stack height, or if I turn that from a fugitive source, capture it, and route it through a stack. Or there's a variety of things you can evaluate. And from that, you can build your mitigation strategy as what you want to do to reduce your odors. All right, so that was just real quick kind of recap on what we talked about in the first two webinars. For this webinar, our first discussion will be odor control options. So the first thing when you're going to control odor is typically you need to capture it and get it to that control device. It can be very difficult to treat what you don't capture. And this picture kind of shows you a typical batch mix asphalt plant. As you can see, there are a variety of different activities occurring and different sources where odor can be generated. And trying to capture each one of these types of sources can be, it's a different approach depending upon the type of source. But you need to capture those emissions before it can get to a control device. So odor capture, if it's a stacker process event, this can be fairly straightforward. Typically, this is just done with enclosed ducting or piping system from the point of generation, and then you transport it to the control device. One thing to be cognizant of is, in some cases, it may be easy to capture something, but the volume you may capture might not be feasible economically to treat. One place we've seen this in the asphalt industry is, in some cases, roofing production plants can have very large cooling sections. You could be looking upwards of 30, 40,000 cubic feet per minute of air. And while these are coming out of a stack, which could be easy to capture it, treating 40,000 CFM of air might not economically be feasible. So you have to kind of think about both. Once it's captured, how do I treat, or is it possible to treat that volume of air? Capture on shingle production lines, also something we see in the asphalt industry. Shingle production lines can be a little bit of a challenge, only because material needs to move in and out of that enclosure, which makes sealing and ensuring capture of all emissions a little tricky. A lot of times operators also need access to the line during operation. So you also need to make sure that it's accessible to people, which again, you have to go through that enclosure to do that. So a lot of times we don't necessarily see 100% capture on these systems. You will probably have some uncaptured emissions from these lines. A lot of times they are indoors, and these are typically hot asphalt fumes. So they're going to be buoyant. And a lot of times we will see them rise to the top of the building that's enclosing the shingle production line. And at that point, those emissions may go through a building vent, or they may go through a door that's opened in the building, and then it's a different point of capture. So they all have their own challenges. And the next one are fugitive components. And when I speak to fugitive components, I'm meaning more on a piping fugitive components. So these would be common at a refinery or an asphalt cements and coating facility, where you have the valves, connectors, flanges, release valves, pumps, compressors. Any of that moving odorous material will have a small leak. And if you're at a refinery particularly, there could be thousands of these fugitive components. Capturing emissions from thousands of components is just not likely. I would say it's not technically feasible. So a lot of the times, to reduce odors from these fugitive components, you're more going to be looking at an enhanced leak detection and repair program. So more frequent monitoring, lower leak detection threshold that would trigger repair of these leaking components, or potentially application of odor neutralizers or masking agents in the vicinity of big piping networks. This is the type of control that you would be applying that can try to be used to reduce odors from these sorts of fugitive components. Next. Another means, if you can't capture it or enclose it, there are ways to try to do barriers or windbreaks. And this has been used at several facilities. In this case, this picture showing is a bunch of pine trees that are planted as kind of a windbreak and a vegetative screen to reduce odors. And these pine trees, for example, kind of work from a two-sided approach. One, the terpenes in pine, that odor that you smell, acts as a natural masking agent for odors. So it can help cover up potentially odors that may be perceived as obnoxious. And also the needles or the leaves themselves act as a way to filter odors. So it kind of works as a couple different approaches to reduce those odors, and they have been shown to be effective to reduce some odors from sources that are a little more difficult to capture. So now that we've captured the odors, you have to decide what type of an odor control technology do you want to use to reduce the odors that you've captured. And here we've kind of divided them into 3 different mechanisms for reducing odors. The first is changing the chemical structure of the odorant to be a less odorous compound. Typically, this requires energy input as heat, an oxidizer, or biological activity, and you actually break the bonds of those compounds into less odorous compounds. So that's one technique. Second would be to remove or just filter the odorous compounds from the stream. By doing so, you're reducing the concentration of odors in the effluents. And the third is by using neutralizers or masking agents. And the neutralizer and masking agents, they don't remove or change the odorous compounds, but rather they alter how a person perceives or does not perceive an odor at that point. So a few examples of technologies where we're changing the chemical structure of the odorous compounds. The first is incineration or combustion. Typically, this could be a flare, it could be a thermal oxidizer, recuperative oxidizer. In this case, with combustion, you're generally converting carbon compounds to carbon dioxide and water and some ancillary compounds. Benefit of these, you can get very good efficiencies, 99.99%. If they are recuperative incinerators or thermal oxidizers, you can also recover some of the heat energy. So there are some efficiencies that can be built into these systems, and they're quite effective against organic odors. Some of the negatives, these can have high initial costs. They can require supplemental fuel, especially if you're doing a thermal oxidizer. You might have a lot of natural gas use on that. The oxidizers also do operate at very high temperatures. They're typically 1400 to 1500 degrees. So it's not one of those systems where you just turn it on and off. You know, if you have to make repairs to this system, you turn it off. It has to cool down for 24 hours or so before you can safely access that equipment. And in some cases, if you have very high sulfur containing compounds in your influents, there is the potential for formation of acid gases in the effluent. So you have to kind of assess your stream to make sure that one of these combustion approaches is appropriate. Another technology we can use are chemical scrubbers. In this case, odors are added to a highly reactive chemical. That could be an acid, it could be an oxidizer. And by doing this, the odorous chemicals react in the solution and are removed. You can get effective removal performance even at high hydrogen sulfide concentrations, which sulfurs are commonly found when we have odor issues. It can be economically treats large volumes of air, and they can have a relatively small footprint. Negatives are they can be expensive to build. The chemicals used in them are reactive and hazardous, as they have to be neutralized before disposal, and then you're going to have a periodic cleaning. So a lot of times you'll have kind of a lead lag system where one is operating and one is cleaning at the same time. And the biological scrubbers are another means of changing the chemical structure. In this case, we are actually using microorganisms to metabolize the odorous compounds, and then they release less odorous compounds. These work well with ketones, alcohols, ethers. They can have a small footprint compared to other technologies. But some negatives, they do need equipment to recirculate your water, which can be expensive on the upfront side and operating costs. And then you do have to have lab developed bacterial strains specific to your odorous stream. These are just a few pictures. On the left is a thermal oxidizer, middle is a biological scrubber, and on the right is a chemical scrubber. These are the types of systems they require design. They're not typically off the shelf. Typically, you would have to work with a vendor, and it'd be designed specific to your flow rates and compositions that you're trying to reduce. All right, so the next are examples of technologies that remove or filter odor. The first one is absorption. This is where the odor molecules are captured in the pore space of absorbent materials. This is frequently activated carbon, or zeolite is another material that's used. The positives to this, there's no chemical storage or recirculation pumps required. They're fairly simple systems. You can get cost-effective removal down to 5 parts per million hydrogen sulfide. They also can remove a wide range of compounds when you compare to wet scrubbers, and they're very efficient at removing VOCs. Negatives, you will have spent media that needs to be disposed of or regenerated, and the disposal of that can be messy. Sometimes it can also trigger hazardous waste requirements. If your carbon is treated, the carbon will absorb everything that goes through it, basically, for the most part, including hazardous compounds. So if that waste carbon is now technically hazardous waste, it has to be treated as such, which can just be kind of a maintenance issue and a cost. The absorbents are consumable, so you either have to reactivate it, which means you're going to have 2 different beds, and one's being reactivated, which may require another control device like a flare, or you're replacing it. And then something else, as the influent concentration increases, the life expectancy of that absorbent material decreases. So if you have a very strong stream where you're going to have to be replacing your carbon frequently, that may not be the best fit for you, because it'll be very expensive to replace that all the time. Biological filters pass the air through soil, compost, wood chips, any other organic material, and as the odors pass through the material, a thin biofilm is developed on the surface, and then microorganisms eliminate that odorous compound. So some nice benefits of this, the bacteria used are naturally occurring, and they can metabolize many organic compounds. They generally work on odors that are biodegradable and water soluble. They're fairly easy to maintain and can remove VOCs. Some negatives, they do typically require larger footprints. You need a pretty long residence time for the microbes to interact with the odorous compounds, and that long residence time typically requires a larger footprint to create that residence time. And the material must be replaced maybe every 3 to 5 years. So unless you have a standby unit, you'll have no odor control during that rebuild process, and then there's a cost associated with that rebuild. These are just 2 pictures. On the left is a biological filter. You can see, I think this is a wood chip filter that's doing an odorous compound removal. And on the right is a carbon filter. And the last are examples of technologies that neutralize or mask odors. So odor neutralizers work on a couple different chemical processes, including absorption, and gas solubility to reduce perceived odors. Basically, when the neutralizer comes in contact with the odor, it attaches to the odor molecules and kind of surrounds it or absorbs the molecule, thus neutralizing the perceived smell or perception that a person gets from it. They're generally produced from natural ingredients and non-hazardous materials, which is a good benefit. And there's a variety of applications. These can be applied. There's vapor phase systems, atomization systems. Some are even additives you add straight to asphalt that can reduce odors of the asphalt use down the road. Some negatives, there's going to be ongoing cost of your odor neutralizer. You're having to constantly purchase this. And the odor neutralizer needs to be selected to your use. There are a variety of neutralizers out there that work with different compounds. If dispersing, the system needs to be designed to make sure you get good contact between the neutralizer and the odor, otherwise they don't work. And then as an additive, we have seen some examples where it may not work at elevated temperatures. So as an additive in asphalt, you need to be mindful of at higher temperatures, they may not work as well. Masking agents, on the other hand, they don't neutralize the odor, they hide it. So you perceive the odor of the fragrance versus the odor of the source. They do come in many scents, and they can cover a broad range of odors. And they can be applied outside of facilities so they don't impact your finished goods. Some of the negatives, again, it's going to be an ongoing cost for that masking agent. Downwind from sources, you do sometimes see that the odors come back as that fragrance kind of dissipates. So the odor isn't gone, it's just being hidden until that masking agent is no longer present. And we have seen in some certain cases where it has triggered public awareness. When the public gets used to the fact that every so often we smell this cherry smell coming from the facility next door, they associate that cherry smell with covering up an odor. And every time they smell that cherry smell, it just reiterates to them that there's a problem or an odor occurring. So that has been seen, something to be mindful of if you're using a lot of masking agents. This is just a picture of some of the application systems for these neutralizers. A lot of times they're kind of a sprayed or atomized vapor phased that's you can, it's nice because you can apply them to areas that can't be captured. But it does require a lot of that neutralizer having to pay for those costs as you're using it up. The next section I will hand over to Paul, and he's going to talk about how to develop an effective odor abatement plan.
Thank you, Tia. Great job. Thanks for the handoff. So I'm going to talk about the role of an odor abatement plan. And the reality is you want to be a good neighbor. You want to reduce regulatory and nuisance risk, litigation risk related to odors to your facility. And so in doing that, you need to reduce impacts related to airborne or odor-causing compounds emitted from your facility. Not just how they're emitted, but potentially not just that they're emitted, but how they impact the community. So one of the main things of an odor abatement plan is identifying your location. How are you sited? How close are you to sensitive receptors or the public access? All of those things are going to influence your odor abatement plan and how you control odors and your need to control odors. One of the critical things to do is plan ahead, especially if you're at the phase of designing a facility. Thinking about odors and odorous impacts can reduce costs down the line. Also talking to potentially impacted neighbors so that the first time they see an odor or aware of your facility is due to an odor impact is not a great introduction. Determine the appropriate odor control method specific to your facility type. This is important. It includes engineering controls as well as administrative controls, possibly some operational controls, when and how you do things, locations you do things, so you can reduce impacts to your neighborhood. Maintenance plan needs to be included in an odor abatement plan. The plan, how do you assess the effectiveness of your filters and your systems, and plan to check and make sure the maintenance is occurring. And then also the use of technology and audits to find leaks, to find and overall to defend against complaints. Using meteorological data is a great way to determine whether or not you could potentially have been the source of a complaint, or if you were upwind, or the location was upwind at the time of the complaint and it couldn't have been you. Potentially use solutions from other industries. There's oil or odor issues have been issues for certain industries for quite a long time, and they've been handling them. So some of those solutions can be directly applied to the asphalt industry. And one thing to note is that all of this is cyclical and connected. Each section of your odor plan is somewhat connected to the other sections and inform how those other sections need to be written. So just the main features of an odor abatement plan. As we said, facility description and location, and then, with that, facility name, address, vicinity map, process flow diagrams showing the locations of your odor emitting sources, identifying their odor emitting activities, how and when they occur, operational considerations, and then odor control strategies and best management plans. So what are the ways you're going to control your odors? From administrative controls, engineering controls, maintenance requirements, training of staff, and then a complaint management system. The facility contact information of where do people lodge complaints? How are those complaints managed? What procedures do you have to respond to a complaint, and how do you reach out to the community once complaints are resolved or looked into? And then if you do have complaints and you are having odor impacts, what is your corrective action plan? What are you going to do to assess and mitigate those impacts moving forward? One of the main, factors in regards to a facility's opportunity or chance of impacting neighborhoods is obviously its siting. It's a critical factor. And if you have the opportunity to site your facility in a location that is not upwind from sensitive sources, if you're can stay in an industrial or agriculturally zoned area much better than being abutted next to a residential zone or having a school directly downwind or an old folks home. All things are if you have the opportunity to site your facility away from sensitive receptors at the beginning, it is the way to go, and a great way of minimizing your potential for impacting neighbors. So identification of your odor sources. That's one of the key parts of your odor abatement plan is identification of your odor sources. So this would entail a comprehensive inventory of your odor generating and handling. This could be your material handling and storage, processing operations, and in previous webinars, we went through all the different types of odor generating activities that asphalt plant handles, and they include also, waste handling and storage areas. And then you also want to identify specific phases and emission points. Where are they being emitted from? Are they fugitive emissions, uncaptured emissions? Are they ducted emissions? What are the flow rates of those ducted emissions? All of those will impact your potential ways of mitigating that source. Evaluate potential odor pathways. So point sources, stacks, fugitive sources, area sources. Each of the different types of sources will have different mitigation techniques and allow you to prioritize which ones will have the greatest benefit for reducing impacts to your neighbors. Document your facility layout and your proximity to receptors. Where are your buildings, and what is your wind direction most of the time? And so document all those things so you have those understandings of how your operations can impact. And then detail the operating conditions influencing odor generation. Are you doing batch processes or continuous? Are there delivery schedules that can affect it? Are there seasonal variabilities where the throughput significantly changes during certain seasons and is significantly less than other seasons? All of those things are important parts of an odor abatement plan, and within it, that identification of odor source. So after you've identified your sources, you need to now detail how you're going to control them and what best management plans, administrative controls, or engineering controls you're going to implement. Those engineering controls include capture systems, enclosures with negative pressure areas to make sure that the odors you're generating are getting collected and pulled towards a collection device. And then there's the treatment systems. Tia just went through all of the different type of treatment systems relative to the odor source type. There's also operational BMPs, doors, hatches, and access points, making sure that those are closed, containing and sealing waste materials immediately. And this has to do with training and keeping people aware that odor is an important part of operating a facility. Oops, sorry. And then there's also the preventive maintenance portion, routine inspection of odor control equipment, filter media replacement and system performance checks. Depending on your odor mitigation equipment, you need to detail how you're going to maintain it and ensure it's working properly. And then you should need to assign an odor management lead for the facility. Who's responsible for the oversight inspections and implementation? If no one's responsible for it, the work it will not get done. Conduct routine odor inspections and logging. These can include daily walkthroughs, verify the system's performances and best management plans you have in place are operating, and then do routine qualitative odor audits of your facility and your odor control equipment. Another portion of your odor abatement plan is going to be your complaint management system, and this is really a critical portion of how you work with your neighbors if you are having odor complaints. And you need to have a complaint management system that has utility, that works for both the facility and the impacted neighbors. And it's important that you have a facility odor point of contact that is responding to these things. So there's not a whole bunch of people who are doing dissimilar responses. This needs to be fairly uniform, and it needs to be done under a method so that the data is being intaked in a method that provides utility to the company. And so you need to standardize the complaint process. You need to understand when a complaint is being lodged, it's important that the location, the time, the duration of the odor event, the meteorological conditions, and observations of the character are taken into the complaint process. That way you have utility, and when that information comes in, you know the details of why that complaint was logged. The complaint tracking database needs to be able to log all of them for trending, for heat mapping, for finding the frequency of impacts at specific locations and overall. Rich complaint data helps inform source attribution, what operational things were going on at the facility at the time the complaints occur, or what meteorological conditions are existing every time a complaint occurs. It also captures the real-world exposure of people downwind, or people who are lodging complaints. And it's a direct linkage to the community experience. And the complaint management system should allow for heat mapping and source attribution and odor event validation. Was it you or not? You should be able to use this to protect yourself, so that if a lot of complaints are being lodged that aren't the cause of your facility, you can be able to show that due to looking at the meteorological conditions, the impacts at your facility, your own observations, or other parts of your complaint management system. If chemical analysis, if you collect a sample after following the complaint, it could also inform whether your source or a different source was the source of that complaint. So once you've had enough complaints, or you've determined that you are impacting, what will trigger criteria for corrective action? That needs to be in your corrective action plan portion of your odor abatement plan. So what is the trigger criteria for corrective action plan? Is it verified complaints, the number of complaints? Is it equipment failure? Or is it an odor exceedance of a certain value that triggers, or a multiple of those types of things? The corrective action plan needs to have a root cause evaluation. So is it you? Are you the contributing source? Or is there a specific subsource at your facility that is causing the conditions? Are there operational considerations or conditions that have changed that are creating the odor? Or were there system performance issues? So a root evaluation of the complaint, or what is causing the complaints or the odor impacts, needs to be included in the corrective action plan. You need to implement targeted corrective measures. So not just check the box, we tried something. You need to implement corrective measures that have science behind it? Are there equipment adjustments? Is the throughput of an odor control device too fast for it to be reaching the odor detection or odor removal efficiency that it was designed? Is there breakthrough in your media? Does it need to be replaced or repaired? What type of operational changes may be needed? Is it timing, or is there some material handling practices that can be changed to reduce odor impacts? Establish short-term and long-term actions. What can be done today? What can be done to right now reduce the odor impacts to the community? And what can we do long-term to ensure that the odor issue doesn't return, and that long-term those impacts are minimized? And then document and track corrective actions and outcomes. This is important for a lot of reasons. For one, your liability. You're also your ability to assess upgrades. Was it beneficial? Did we spend money on this corrective action or this odor mitigation? Was it effectiveness? So you need to be able to assess that through follow-up inspections and monitoring. So what are the key understandings and common mistakes made during odor abatement plan development? Like I said before, location, location, location. It's very, very important to understand your location. Your need for mitigation is going to be directly tied to how close sensitive receptors are and residential areas and people who can complain. There is a critical industry need for odor abatement planning. There's the rate of complaints have significantly increased, not just for the asphalt industry, but overall throughout all industrial processes. And industry growth means increased odor challenges. This is also because the space between odor sources and the community is shrinking. Oftentimes, the source was, when designed, out in the middle of nowhere or not near residential areas, but now residential areas are encroaching on those odor sources, increasing the challenges for these types of sources that have existed for a long time. But it's really the change of their surrounding area that has increased their odor impacts. It's important to have science-driven and quantifiable solutions. You need to look at your odor impacts and your concentrations, and to be able to assess, are you actually reducing them? And if you're applying a source, are you achieving the measurable odor reduction that was sold to you from the odor control device? Proactive odor control works best. When you're reacting to odor control or odor impacts, the community is already angry. If you're addressing odor impacts prior to community complaints, if you're addressing odor impacts at your fence line prior to making those odor impacts reaching neighborhoods, that is a much better approach. Get an on-site meteorological station. This is advice we give to everybody that is a potential odor source. This will protect you and also inform you in regards to how odor impacts occur at your facility, when odor impacts and complaints occur. And it also can protect you and let you know that at times complaints are occurring and lodged against your facility when your facility is very unlikely to be the source of the complaint due to wind direction. And community engagement and complaint tracking is essential. If you don't have that information, that void will be filled with by the people in your opposition. So have quality data, collect your quality data, engage with the community, and make sure that complaint tracking is occurring and that you have a diligent system for it. And now that we've talked about the odor abatement plans, we'll talk a little bit about community outreach, the importance of it, and kind of methods that work for outreach to the community. So like we said, be proactive. Don't wait for complaints to occur. Share updates about your facility upgrades on a company website. Install a meteorological system prior to facing complaints. Manage your incoming complaints. have a complaint management system that's easy for the public to use. You should potentially have multiple ways for them to lodge the complaint. You would rather them lodge the complaint to your facility than to a government agency or start calling lawyers. You'd rather them be calling you to help mitigate the situation, work together with the community. Prioritize timely responses. If somebody's lodging a complaint and it's taking days for you to respond to them, that odor's no longer there. A lot has changed, and you're not going to get a lot of cooperation from the community members if you're not prioritizing timely response. Ingest data with utility. So if you're getting complaints, it's important that the location of the odor observation is tracked, the time of day, the character of the odor and the odor description, how long the odor was experienced. All of those things are very important in regards to your response. So make sure that you're ingesting data that has utility for remediation and response. We've always thought that it's better to have a partnership with the community in resolving odor situations than kind of a rivalry or an antagonistic approach. They always work better. Once you have that antagonistic approach, the community will not trust you anymore. And whether or not you made great improvements in regards to your odor impacts, it's not going to be as beneficial if the community doesn't trust you. It helps to hold regular meetings with local leaders and residents. Share the data that you have, especially data that shows improvements and shows that you are doing proper assessments and that you're serious about reducing those impacts to the community. Having real-time data dashboards on a website that the community can access that shows maybe some concentrations of measured pollutants at a fence line, meteorological conditions, that displays some of the operational considerations at your facility, and then provides them with contact information for your facility specific contact for odor issues. That's all important. Having facility open houses, letting people, come to the facility, meet the people, shake hands. It's people are less likely to complain to regulatory agencies if they know the people behind the facility and know that they're humans as well, trying to make a living. Educational mailers about improvements that you've done. Also inform the community that you're serious about odor control and you're working towards an odor-free community. Working with your neighbors. So maintain open community, build trust with the community from inception. Here's a kind of a little picture of a meteorological site that could be on the rooftop of your facility, logging information that has great utility for response to odor complaints. Assign your odor point of contact. This individual who needs to respond to the odor complaints in a timely manner. Shares the contact information with neighbors. Logs complaint in the complaint management system. If it's not automated, if it's not an automated system, reviews on-site meteorological data in association with the complaints, reviews their systems following odor complaints, looking for potential upset conditions or failures of control devices or different types of operations that may have led to that complaint, and then responding back to the community of what you found. Looking for nuisance odor vectors, open doors, poor waste stream management, or they may conduct their own odor study or hire a third party to conduct an odor study. So the benefits of collaborative and planning, it's obvious, and it's in the data. Complaint reduction. If you invest in odor control, you're going to reduce your odor complaints. We found that the data shows that investments in odor control systems or locations that do that reduce odor complaints by as much as 50 to 75%. It gets the community to buy in. A study shows that community engagement reduced odor related to complaints by 50% within 6 months of implementation. That is just simply engaging the community and showing them that you're serious about odor control. The secondary benefits of odor planning and odor control can include increased material yield, reduced risk of employee concerns, and a healthier and improved working environment for your employees. So thank you very much for your time today and your consideration. And if you have any questions, you can reach out to us. And I believe there may be some questions in the Q&A.
Shyla, you're on mute.
That's the trick, huh? All right. So first of all, I said thanks to Paul and Tia for their time and their sharing of all this great information. The question in the Q&A asks, can you give an example of an odor masking compound for asphalt? So is there a specific compound that you guys have found works well for asphalt fumes?
Well, so I can speak to this a little, but in general, the companies that provide odor masking or odor mitigation for asphalt or any source, they keep their solutions proprietary and so they don't exactly tell you what's in the solution, but they will give you the safety features related to it, and they can show you that there's no health concerns related to the thing. The companies that we're aware of generally utilize essential oils of various different types and compositions, but I don't have an example of a specific compound. For one, in general, those are proprietary and held in confidentiality agreements. And then two, there's depending on your asphalt composition, the type of source that there may be a slew or composition of chemicals that are utilized.
All right, thanks, Paul. And for the questions, I believe Tia and Paul's contact information is included in there on the slide. So if you have a question you want to direct a more pointed question to them, feel free to reach out. I don't see any more questions on the Q&A. This presentation will be available on Asphalt Institute's YouTube channel along with the other ones, and definitely appreciate everyone's participation in this seminar today. Have a wonderful Tuesday, guys. Thank you.
Thank you.
Thank you, Shyla.
Thank you very much.